Okay, maybe we'll get done this time. It says find the domain of the rational function. Well, first thing you got to do is factor this thing out. It doesn't really matter if it reduces or not. Yes, that determines vertical asymptotes and removable discontinuities, but either way you go, there's something missing. You either have a vertical asymptote there, or you've got a hole in your graph. So one way or the other, your denominator can't be 0. So quite honestly, you could have just set your denominator not equal 0. And we can do that. We can just do x, and then this thing right here can't be 0. Well, if I do that, I get x can't be 0, and then this right here, that's going to be x can't be 4, and x can't be negative 4, because it factors. Or you could just do x squared equal can't be 16, do the square root. But you can't have those three things. Now, if you'll put them in order, think about it, you have holes there. You have a hole at negative 4, you have a hole at 0, and it could be a vertical asymptote. And you have a break there, so let's just call them a break. Everything else works. So we need to represent all of those intervals. So first interval is negative infinity up to negative 4. Then we're going to start over at negative 4 and go to 0. Then we're going to start over at 0, and then we're going to go to 4. Then we're going to, oops, forgot my union, didn't I? Okay. Union 4 to infinity. There we go. So that's your domain. You had 3 little breaks in it. So when we graph this, vertical asymptote, see, nothing factors and reduces, so that is your vertical asymptote when you set the bottom equal to 0. So x equals 2. Horizontal asymptote, look at your powers, your degrees. You have 1 over, and in the top, 1 in the bottom, so since they're the same, you stack up your leading coefficient. Well, that's a 1 over 1, so we have y equals 1. So you got to remember your rules for horizontal asymptotes. When you come in here, you can go ahead and graph those. X equals 2 and y equals 1. Now, it is very beneficial to find your x-intercept and your y-intercept. Okay, so x-intercept means, remember, it's the top equals 0. Well, if I do the top equals 0, that's just x equals 0. And I tell you what, it's not a line, so don't write it that way. It's an ordered pair. X is 0. So the y-intercept, if you let the x's go to 0, think about what that's doing. That means y equals 0 on top, 0 minus 2. That's just 0, because 0 over anything is 0. You should have been suspicious, because anytime the origin pops up, it's both of them. So it's hitting the origin right there. That has claimed this sector of the little grid marked off by the blue asymptotes. So you know it's going to approach here, and it's going to approach here. This asymptote had a multiplicity of 1, so when it goes away down at the bottom, it's going to come back from the top, and it's going to fill in that section. And so you've got your graph. Okay. Well, we've moved on to logarithms. We need to swap forms. So if we swap forms, you've got your base raised to your power equals 27. Now, I need everybody to have the same base. Well, 3 is it. So I need to turn this 1/3 over. The way you do that is you pick up a negative in your exponent. We'll rewrite 27 as 3 to some power. Well, that'd be 3 to the 3rd. So now that my bases are the same, I can set my powers equal and solve them out. So x is a negative 3. There we go. All right. When I solve this equation, I first need to condense it, so I've got to have it down to 1 logarithm on the left side, and I can't go through and just do, kind of drop the logs off, because over here on the right side, it doesn't have logs, so that prohibits you from going through that. You've got to use your condensing rules. This is plus, which means when you condense, that means you multiply. So I've got x times x minus 3 equals 1. Okay, now you can go through, and you know that base is 10. So what we had done is you take whatever your base is and use that on either side. These now cancel, and I'm going to go ahead and distribute that as x squared minus 3x. And over here, this is 10 to the 1st, so that's 10. So move your 10 over, because you got a quadratic, you got to try to factor. And what two numbers multiply to 10 and subtract to 3? Well, that'd be 5 and 2. Signs are different. Big one's negative. So x is 5. And x is negative 2. Well, if you remember what I told you, if it starts as a logarithmic equation like this, most likely the negative answer is not going to work, but plug it in and just see. See, if you put the 5 up here, it's log of 5, and you put 5 there, it's log of 2. That's appropriate because remember logs, they don't go into the negative realm. Your domain doesn't. So if you put -2 up there, you start immediately with log of -2. Well, that's bogus. You can't do that. So the negative's gone. This is your only answer. Okay, now this is the easy one because if you'll notice it has log of this equals log of that. The bases are the same, but since it's log equals log, they basically cancel out. Since the bases are 10, what you're really doing is you're putting 10s on either side, and so these cancel, and you just get 9x minus 7 equals 3x plus 11. So put your x's on one side, that's 6x, move the 7 over, that's 18, so x is 3. Nothing wrong with a 3. If I put a 3 in either one of those, it comes out positive, so it's fine. Okay, now this just like exploded with logs. So you're going to have to condense because it's got to get, just like the equation that we just did, log equals log before you get rid of stuff. So, look, you can do it the way it is and go ahead and build the fractions, or you can be sneaky and move things so you multiply. It doesn't matter to me, so I'm assuming that y'all want to be sneaky. Let's move him over here, and let's take this guy and move him over there. Now, if we do that, here's the reason why. I'm taking this one and bringing him over. He's now going to be positive. All right? Now, my front guy's the same over here, but I'm bringing over the dude from the other side. Well, he's going from negative to positive. Okay. Now, when I condense, I don't have to worry about fractions. So, but I do need to multiply these two. So let's just go ahead and multiply them together. That's x squared minus 8x. Using parentheses is wise there because you got a binomial. All right, same thing here. I got log, and then I've got to distribute, so that's going to be 3x minus 18. And again, using parentheses is wise. These logs cancel. So you got x squared minus 8x equals 3x minus 18. That x squared declares that everything has got to come join him. He's positive, so they all need to come running. Okay, so that's going to be x squared, what is that, minus 11x, and then make your 18 go over. Positive 18 equals 0. What two numbers multiply to 18 and add to 11? That would be 9 and 2. Sign to the same, both negative. So x is 9 and x is 2. Now, you want to plug them in and verify that they both still give you positive answers. Now, so if I put 9 here, yep, that's positive. If I put 9 here, yes, that's positive. 9, yeah, 9's positive. Put in a 2. 2 minus 8, uh-oh. That didn't work. 2 minus, so as soon as you get one that doesn't work, he's out. So he's not a negative, but he's negative when you plug him in. So you got to check them just to make sure. Okay, next dude. Use like basis to solve this exponential equation. Well, we have to rewrite 81 with a base of 3. So that's 3 to the 4th. Now that your bases are the same, your exponents must be equal. So the 5 goes over, divide it out, x is 3. You don't have to check anything on exponential equations because remember the domain of exponential equations is, or exponential functions is everything. So this thing says solve. Well, there is no way we can rewrite those things as having their same basis. So what we can do is we can come in here and say, okay, I want to get rid of this 8. So I'm going to do log base 8 on both sides. Now I know some of y'all use swapping forms and everything, and that's fine. Do whatever works for you as long as it's legal. So those two cancel out, and I got x, so this is your change of base rule. Remember the base goes in the basement. Okay, when you type it in, just be careful. Don't either close your parentheses or type it separate. So log 17 divided by log of 8 is 1.3625. There we go. All right, so solve this thing. Well, I need to get rid of the e. Here, let me just rewrite it over here. I don't have enough room up there against the wall. Okay, so I'm trying to get access to my x. So the e's got to go. So I need to squeeze in an ln. I know that'll kill off my e. So x plus 2 is equal to ln of 10. I need to move the 2 over, so that's negative 2 plus ln of 10. You don't want to interact with these. So that's the reason I put it at the front on purpose. So it wants decimals though, so negative 2 plus ln of 10, 0.3026. Okay, so solve the system by substitution if possible. Really doesn't make a hill of beans difference how you solve it, just as long as you get it done. This thing's equal to y, so all this needs to go into place of y. So 7x minus, just make sure that you lead it off with parentheses, okay? Otherwise you're going to lose your sign and everything's going to be weird. So that's going to change them all. Should be a plus 31. So that would be a negative 2x. When you move the 31 over, let's see here, 23 minus 31. I should be able to do that, but my head hurts today. X is 4. If x is 4, take that and put that back into that first one. Y equals 9 times 4 minus 31. Well, that's 36 minus 31 is 5. So your answer is the ordered pair 4, 5. Okay, we're going to solve this system. Well, I need to shoot for the same thing. Even though these signs are different, I'm more interested in the x's because all I have to do is mess with one of them. So I'm going to multiply that one by negative 8. So it'll be a negative 80x plus 56y equals, and I have no idea what that is, negative 8 times 43 is a negative 344. Okay, so I'm going to add these two up. My x's are gone. That's going to be 59y equals, let's see here, negative 344 plus 403 is 59. Aha, so y is 1. Okay, so put it back into either one of them, it doesn't matter. So 10x minus 7, right, since y is 1, equals 43. So 10x equals, if I add the 7, I get 50. Divided out, x is 5. So I got 5 and 1. Okay, so solve the system if possible. I'm looking at that, and the z's look terrific. So remember, this is a 1, 2, and 3. So I'm going to do this really quick. I guess it's no sense in me doing it that quick because I'm going to have a different video. So I might as well just do it the old-fashioned way. So x plus y plus z equals 14. And 3 is 2x plus y minus z equals 21. Put those together. We got 3x plus 2y, and the z's cancel out, and I've got 35. Okay, so do a different set. So I'm going to do, I know I want 3, so, because I got to have me a negative. All right, so then I did the 1, so let's do 2. 7x plus y plus z equals 68. All right, if I put them together, I got 9x plus 2y. Z's cancel, and that's going to be, what is that, 89? Okay, now whenever I look at these, and these are my little 4 and 5, you know, when I put them together, my y's are looking pretty good. I just need to change the signs. So I tell you what, let me put 4 under here, and I'm going to change the signs when I do it. So negative 3x minus 2y equals negative 35. So that would be a 6x. Y's are gone. So 89 minus 35 is 54. So 6 goes in there. Let's see here, 9 times. So I can take 9 and stick it in one of these. Doesn't matter which one. 3 times 9 is what, 27? Plus 2y equals 35. So if I subtract 27, 35 minus 27 is 8. So y is 4. So now I can go back to first one. My x is 9. My y is 4. Z, I don't know. And I got 14. Well, that's 13, right? Well, 13 plus what gives me 14? That's going to have to be a 1. So that's supposed to be a z. It just smeared. So x, y, z. Oops. Ordered triple right there. Okay. Now, let me, I'm just going to have to do the rest of them in the next video. Sorry.